Good day friends, welcome to my channel lecture series on power electronics. In this session, we'll learn about regulated power supplies, commonly abbreviated as RPS. An electronic circuit that produces a stable DC voltage of fixed value across the load terminals irrespective of changes in the load is known as regulated power supply. Thus, the primary function of a regulated power supply is to convert an AC power into a steady DC power. The regulated power supply is sometimes also called as linear power supply. Let us see why regulated power supplies matter. In the case of an unregulated power supply, the output voltage drops or surges depending on how much current the device is pulling. A regulated power supply protects delicate electronics. In the case of an unregulated power supply, when the current drawn by the load increases, the voltage would drop or surge, whereas that does not happen in a regulated power supply. A regulated power supply protects delicate electronics. It provides clean power with minimal ripple. Ripple is an unwanted AC variation that is minimized in a regulated power supply, and it ensures that devices like computers, medical equipment and lab instruments do not suffer damage from power spikes or instability. There are two main types of power supplies. Regulated power supplies are categorized into two primary designs based on how the regulator works. One is a linear regulator, the second one is switch mode power supply, commonly referred to as SMPS. In the case of a linear regulator, they operate by dissipating excess power as heat. While they provide very clean, low noise power, they are less efficient and bulkier. So linear regulators, though they are providing a clean and low noise power, they are a little less efficient and they occupy more space, being very bulky. The switch mode power supplies SMPS, they rapidly switch a transistor on and off to maintain the target voltage. Because they make use of the switching process, they are highly efficient, lightweight and generate very much less heat compared to the linear regulators, but they can introduce some high frequency electrical noises into the circuits. So the two main types are linear regulators and SMPS. Based on the application requirement, the type of regulators are chosen. If the efficiency does not matter or the space does not matter, then in that case we can go in for linear regulator. But if the efficiency requirement is high and the weight should also be less and less heat has to be generated, in that case we can go in for a SMPS. In this session we will be dealing only with the RPS, regulated power supply. In the future sessions, we'll go in for the SMPS. We are going to deal with linear regulators in this session. The block diagram and operation of regulated power supply is shown in this image. The major parts of the regulated power supply are a step-down transformer, rectifier circuit, DC filter circuit, and a voltage regulator. The main function of the step-down transformer here is to reduce the AC input voltage from a higher level to the lower level. It also works as a electrical isolation between the two circuits. The reduced output AC voltage of the step-down transformer is used as the input to the rectifier circuit. The rectifier circuit is used to convert the AC input voltage into a DC voltage. It consists of diodes that perform the rectification process, that is the conversion of the AC voltage into the DC voltage. However, the output of the rectifier is not a pure DC, it is a pulsating direct voltage. In practice, a full wave rectifier or a bridge rectifier is used for the rectification purpose because of its technical advantages. This full wave rectifier can be a center tapped full wave rectifier or it can be a bridge rectifier. The full wave rectifier converts both the positive and the negative cycles of AC voltage into a DC voltage. Let us now understand the function of the filter circuit. Since the output of the rectifier is a pulsating direct voltage, which has a very high ripple content, it has to be filtered before it is fed to the load. The raw output of the rectifier is undesirable. In order to get a pure ripple-free direct voltage, the DC filter circuit is used. We have different types of filter circuits such as capacitor filter, choke input filter and LC filter. Filter circuit converts the pulsating direct voltage into a constant direct voltage having almost zero ripple content. So the output of the filter circuit will be a pure DC voltage. The purpose of using a voltage regulator in this RPS is explained like this. The voltage regulator constitutes a last block of the regulated power supply. It monitors and corrects the fluctuations in the output voltage of the power supply. The output voltage may change or fluctuate due to any change in the input AC voltage or change in the load or change in any physical parameters such as temperature of the circuit. Thus, the voltage regulator takes care of this problem. The voltage regulator maintains DC voltage constant at the output terminals. A Zener diode operated in the Zener region, a transistor, series voltage regulator, fixed and variable IC regulators are commonly used in different regulated power supplies as a voltage regulator. There are different types of regulators available. Regulators can be classified into different categories depending upon their working and the type of connection. Depending upon the type of regulation, the regulators are mainly divided into two types, namely line and load regulators. Line regulator is a regulator which regulates the output voltage to be constant in spite of the input line variations, is called as a line regulator. Load regulator is a regulator which regulates the output voltage to be constant in spite of the variations in the load at the output. It is called as a load regulator. Depending upon the type of connection, there are two types of voltage regulators. They are series voltage regulators and shunt voltage regulators. Thus, the regulators are classified based on the type of regulation, whether it is line regulation or load regulation, or depending upon the type of connection, a series voltage regulator or a shunt voltage regulator. Depending on the type of connections, the regulators can be referred to as series voltage regulator or shunt voltage regulator. Let us see in this image. The series voltage regulator is a regulator which is connected in series with the load, whereas a shunt voltage regulator is just connected in parallel to the load. Based on the application, the regulator is chosen. Some of the features of the regulated power supply are they have efficiencies ranging from 20 to 25%. They are relatively more reliable. The regulated power supplies have less complex circuit and less weight. They give faster response. The cost and the noise level of the regulated power supplies is low. Regulated power supplies find applications in mobile charging circuits, testing circuits, bench power supplies, oscillators and amplifiers, electronic computers, automatic control systems, etc. The term regulation in a power supply refers to its ability to maintain a stable output voltage despite variations in the input voltage, that is called as line regulation, or changes in the load current, that is load regulation. Essentially, it ensures that electronic devices receive consistent power, preventing damage and ensuring reliable operation. Line regulation is the ability of the power supply to maintain a constant output voltage despite the changes in the input line voltage. A good line regulator minimizes the impact of input voltage fluctuations on the output voltage. For example, if the input voltage drops slightly, the regulator will compensate to keep the output voltage within acceptable limits. One example is if the input voltage drops from say 12 volts to 11.5 volts, the output voltage only changes from 5 volts to 4.99 volts. This is an example of good line regulation. It is often measured as a change in the output voltage for a change in the input voltage, sometimes as percentage. Load regulation is the ability of the power supply to maintain a stable output voltage as the load current changes. A good load regulator keeps the output voltage constant even when the load, that is the device which draws power, demands more or less current. For example, if you turn on another device that draws more current, the regulator will compensate to maintain the output voltage. Example is, if a power supply provides 5 volts at no load, and when the load is connected to the output voltage, the voltage drops to 4.9 volts. The load regulation is how much the voltage is changing with the load change. It is measured as a change in the output voltage for a given change in the load current, sometimes as a percentage. To summarize, line regulation focuses on the input side of the power supply, whereas load regulation focuses on the output side of the power supply. Two other important terms related to the RPS are output ripple and transients. Output ripple and transients are undesirable AC voltage variations present in the output of a power supply, particularly switching power supplies. Ripple is the residual AC voltage related to the switching frequency, while transients are high frequency oscillations occurring during switching transitions. Both can negatively impact sensitive circuits connected to the power supply. Ripple is the periodic AC voltage fluctuation on the DC output of the power supply, stemming from incomplete AC signal suppression after rectification. It is fundamentally linked to the switching action of the power supply, with its frequency often matching the switching frequency or its multiples. So depending on the switching frequency, the ripples present in the output voltage will differ. Ripple is caused by the charging and discharging of the output capacitor and inductor, as well as the switching noise. Output capacitors, especially their equivalent series resistance ESR, play a crucial role in minimizing ripple. Transients are short duration voltage spikes or dips that occur when the load connected to the power supply changes abruptly. This can be caused by sudden changes in the load current, leading to voltage overshoot or undershoot. Accurate transient measurement requires careful oscilloscope probing techniques to minimize loop area and avoid distortion of the signal. It is often required to measure and minimize the ripples and the transients. Ripple and transients are typically measured using an oscilloscope with attention to probe placement and minimizing loop area. Proper measurement techniques are crucial for accurate assessment of ripple and transient characteristics. Output capacitors, inductor selection, and a careful circuit design can help minimize ripple and transient effects. Understanding the power supply's topology and component characteristics is essential for effective ripple and transient reduction. Thank you. Thus, in this session, we have learnt about a regulated power supply, the block diagram of it, the major parts of the regulated power supply, line regulation, load regulation, the applications of the regulated power supply, and some parameters like the output, ripple, and the transients also. Thank you.